Window? Yes, ma'am. Service camp. Yes, ma'am. I combine magic and science to create illusions. I work with new media and interactive technologies, things like artificial intelligence and computer vision, and integrate them into magic. Welcome back to the second day of International Workshop on Artificial Intelligence and Machine Learning. I extend a very good morning and a warm welcome to the honorable dignitaries and the distinguished audience. Computer vision has been around for more than 50 years, but recently we see a major which is how computer visions can be used to build products for consumers and business. So few examples are such as applications, Amazon Go, like Google Lens, autonomous vehicles, face recognition, etc. The key driving fact behind all these is computer vision. In the simplest terms, computer vision is the discipline under a broad area of artificial intelligence which teaches machines to see. Its goal is to extracting machines from pixels. With no further delay, I request Dr. Satish Kumar, MCA, Hindustan Institute of Technology and Science, to deliver the welcome address.
Morning everyone, am I audible?
What's more?
Yes, you are audible, sir.
So I extend my greetings to all the participants. It has been a great pleasure in introducing our speaker, Mr. Muhammad Abdul Farid, who have been working as a software engineer in Accenture Private Solutions Private Limited. So he has an immense of experience in the field of ML, and he has worked in the projects like fake news detection, sentimental analysis, Microsoft malware detection, Facebook friend recommendation using Python. So he has more hands-on experience and he has worked in many projects. So we are really thankful to him for taking the time out of his busy schedule to attend this workshop. So welcome Farid sir. So I welcome you to present this workshop. And I request all participants to interact with our speaker and you gain the knowledge in the field of machine learning and computer vision.
Thank you very much, Nikit, sir. It's been an honor to be here, and it's my pleasure to be here. And I'm thankful to Hindustan Institute of Technology and Science for providing me the great opportunity, the Department of Computer Applications for conducting the international virtual workshop on artificial intelligence and machine learning. So I would really thank for the steering committee, Dr. Ramalingam sir and Dr. Angelina Geeta, and the conveners are Dr. P. Ranjana, and the coordinator, Mrs. Sherlyn Ilyas, and the organizing committee, Dr. Rama Prasad and Dr. Satish Kumar. It's been an honor to be here. So my name is Muhammad Abdul Farid. Currently, I'm working in the Accenture. So I'm here to uh, take applications of the Opencv and the Scikit, which is a Python library. And I would like to introduce my colleague, Dr. Muhammad Muzaffar. Uh, he's also working with me in the same department from quite couple of years, and he's working currently on the ML project. And currently, I'm because of the emergency call on the project deployment, I'm occupied with that. So I would like to introduce the Muhammad Muzaffar to take the call. Muzaffar, are you here?
Hey, hi.
Yeah, hi Muzaffar. It's over to you. Thank you.
Yeah, hi, sir. Hi, Satish, sir. And everyone, thank you so much for giving me an opportunity to present. So it's really a great pleasure for me as like I have been working. I have been coding and I have been learning artificial intelligence for my passion. So it's really a great journey for me. Going so far, like I have been working 12 to 14 hours a day to grab the concepts of artificial intelligence and delivering those services as application in terms of mobile apps and web applications. So my recent projects were in ML, and I have also implemented AI modules such as like voice recognitions, face recognitions, and implemented chatbots that uses natural language processing, and user can interact with the chatbot, which are like very engaging. So it's been a really great experience, and I have really thankful for the opportunity to share my experience and like share my knowledge on computer vision. I've also been into the training industry since last 2 years, and I have conducted many workshops for international candidates. And I started with my colleagues, where I used to deliver all these speech, which I was learning in the earlier days. So after that, like we commercialized those things, and uh, we did it in a high scale. So let me just share my screen, and I have something to present. So am I audible, guys?
Yes, sir, you are audible. Can you please
Yes.
come to video mode, sir?
Yeah, sure. I can share the screen actually.
Okay, sir. Is it possible to come to video mode, sir?
Actually, I'm using desktop, and right now it's not possible for me.
Okay, sir.
All
You
right,
can share
thank you
it.
so much. So, yeah, I have a very short seminar objectives here. So let's start with the artificial intelligence, as like computer vision comes under artificial intelligence. So we'll be taking a big picture of it, and going forward, we'll just get into computer vision and understand each and every step of computer vision, how it works, and we'll also implement it practically. We have some two projects to show you like how computer vision and Scikit learn works, and after that, like the last thing is like it's my uh, basically I was waiting for since a long time to invite people to the artificial intelligence. Like I want to present like how great these things are. Like it's so amazing that if you get an idea of it, you can definitely join artificial intelligence. So there is a great motivation behind it, so we'll be talking it in the last. So let's start. So we have been around this terminology, artificial intelligence. We have been hearing it multiple times, and in so many advertisements on the internet, like regarding artificial intelligence and machine learning. There is a great awareness on the social media as well, and even our day-to-day applications are highly adopted with the artificial intelligence. So what artificial intelligence is? It's a multidisciplinary field whose goal is to automate the activities that presently require human intelligence. It's very simple. So we have to automate the things using artificial intelligence. So there are like several technical definitions of artificial intelligence available, but they are very complex or confusing. So we'll explain you the definition with the simpler terms for your convenience. So humans are like considered the most intelligent species on the planet, and because they solve the problems and analyze large amount of data. So by just looking at the problem, we can analyze the problem, and with the logical reasoning, analytical thinking, and statistical knowledge, we come up with a solution. So keeping all these points in mind, AI is being developed for machines. So robots is machines and robots, like to provide the ability to solve complex programs in machines similar to the humans. So by providing the data, so the more data we have, the more the artificial intelligence model will be it will be very strong in terms of data. So we have to provide data to train the model. So artificial intelligence is something, it learns in a different way. So one way is just by providing the data, and another way, it keeps on experiencing new and new things, and that's how like it emerges on itself. So uh, in terms of application, like we have a very huge range of applications in today's life. We can see like artificial intelligence is being adopted in medicine, medical industry, in communication. We have everywhere the voice assistants and voice recognition systems. And in our day-to-day life, in daily lifestyle applications as well, we have the artificial intelligence, where like face recognition features are there, and many more features like which are offered by the artificial intelligence. So electronics, so in electronics, we also have artificial intelligence. Let's say like we have some light bulbs which are like automatically closing in the daytime, or at the when they are in the brightness, and uh, automatically closing AC. So these are like working, they are sensing the atmosphere, like temperature, humidity, light, and after getting those data, they are taking some decision whether to open the light or close. So electronics in industries highly adopting the artificial intelligence. In automobiles, using artificial intelligence, like developing constructions are like done very on a high scale. And as we can see, like it's not a new terminology now, and it's highly adopted. So let's get into computer vision. So computer vision is a field of artificial intelligence that trains computers to capture, interpret the information from the image and video data. By applying machine learning models to image, computers can classify object and respond. So the very basic example is that we open the smartphone with a face unlock. So by looking at the face, it recognizes the face. So it's done using computer vision. So I have described the step-by-step approach how computer vision works. So apart from computer vision, artificial intelligence, it has many fields that are like machine learning, neural networks, deep learning, new natural language processing, cognitive computing, computer vision. So these all works together. So computer vision, when we apply computer vision concepts, we need machine learning algorithms to work on. And to classify images, to identify faces, we definitely use machine learning models. So let me just give you a small brief overview on these fields. So basically, starting with the machine learning. So machine learning is a feature of artificial intelligence that provides the computer with the capability to automatically gather the data and learn from the experience of the problem or cases they have encountered, rather specially programmed or to perform the given task. As like as I have mentioned, like it will be learning by experiments. So it will be collecting the data automatically. It will be creating its own responses. So machine learning, it has many different algorithms like logistic regression, Navier, linear regression. So these are different algorithms we need to use for different situations. And the machine learning encompasses with the growth of the algorithm which can the data make predictions. So mostly machine learning we use for the data prediction. Let's say we want to predict the stock price, what it's going to be the next day. We want to predict whether the customer is going to buy the product or not. We want to predict what will be the strength of class tomorrow, what will be the strength of employees tomorrow. So based on the previous data, we are predicting some future. So that is done using machine learning. And many other use cases, and it also have like pattern recognition, which is the like subcategory of machine learning. It can be described as an automatic recognition of the blueprint of the raw data using computer algorithm. So that is nothing but like a pattern recognition is something like the flow which is being followed. So it has different techniques which we can get into these techniques later on. So let's get into the deep learning part. We understood what machine learning is. It's basically for prediction. It's basically for training the computer to understand the data and interpret the data and use it for the later purpose. And What's deep learning then? So deep learning, it is the process of learning by processing and analyzing the input data by several methods until the machine discovers the single desirable output. So deep learning, it's recursively, it's again and again, going through the data, and until we get the final output. We also have this deep learning implemented in computer vision. I'll be showing you in the last step. So finding the final output recursively by self learning, it will be automatically making the it's automatically categorizing the data. So there is no manual work in deep learning. So deep learning is introduced. uh, Earlier we used to manually select this particular color, this particular feature we need for identifying whether it's a bike or car. There were like many manual process we need to go through, but after deep learning came into the landscape, we have like a very less efforts. Everything is going automatically, and yeah, we'll understand it much with an example in the computer vision. So neural networks. So let's take a look at neural networks. So neural networks are the brain of artificial intelligence. They are computer systems which are the replica of neural connections of human brain. The artificial corresponding neurons of the brain are known as perceptrons. The stack of various perceptrons joined together make the artificial neural network in the machine. Before giving a described output, the neural network gain knowledge by processing various training examples. So we have an example which can show you both the pictures in a example. So here the neural network forms these kind of patterns, and deep learning goes through each and every pattern every time, many times, to identify whether the given input is a car or bike. So to identify the final output, to get the final output, we use neural network and deep learning. So we don't need to do, it's all in a form of modules now. So we are not writing any code from scratch. We just need to import the pre-built modules. So there are like huge members of community which are regularly developing and updating the features. We just need to import those modules, and within few lines of codes we are able to implement the neural network, deep learning, and all these concepts. So you might be thinking like, okay, so these are like very big concepts, so code might be the big, so like code will be very small in terms of implementation. So computer vision, we are going to get into it in a much deeper way, and as the today's focus is on computer vision. So basically we got to know that computer vision is used for face recognition. Like it can process image data or video data. It can be like a CCTV camera where computer vision is applied, and it can identify who is coming, and it can identify thief, it can identify car, it can identify which car model it is. If it placed in the traffic, it can count which how many numbers of bike has been passed, how many numbers of cab has been passed. So computer vision can process huge amount of data in terms of video or as well as images. So the other example for images is like we pass the input with the group of people. It will create a green square on the faces. So it will identify the face, and it will also identify the name. If we provide the appropriate data, it will also provide the name of the person, that this is Adam, like that. So by processing images, we use this computer vision. So computer vision, it's all around us. So self-driving cars, so it's a great example. So how does a self-driving car knows that when to stop or to swear? Computer vision identify pedestrians, sees stoplights, and accesses red read conditions. So it keeps a straight line every time. Basically self-driving cars, they follow the white line on the road, and they follow the track, and the camera is observing everything, who is pedestrian, where is the bike, how much the distance we have, how much the speed of the other vehicle, how much time it's required for us to stop before the signal. So everything, like the camera is passing the input on a real time, so it's capturing the footage and it's passing to the processing system, which is running on cloud somewhere, and uh, the output for that input data, it will be returned to the car, and car is taking some decisions to stop or to put on. So self-driving car in the operation theater, like in operating room, basically computer vision uses real-time image, so surgical images are scanned using computer vision. So in order to monitor blood loss and prevent hemorrhaging, basically there are numerous applications of computer vision in medical industry. Apart from computer vision, machine learning algorithms, like predictions, we have done some project recently which was like prediction of disease based on provided symptoms. So user has to basically, using voice recognition, user have to just say, I had a fever, I had a headache, and I have been suffering from last 6 days, and user is just passing all the raw inputs. And using voice recognition, we first take the inputs, and we identify the keywords. We pass those raw data to machine learning model, and after getting all those symptoms, machine learning model, it loops through the data. We have a huge amount of data where each disease and its symptoms were present. So after looking into the symptoms provided by the user, we were able to identify uh, probably what kind of symptoms he has, and what kind of treatment he can go through. We have just kind of prediction and suggestion, and uh, we also have created a machine learning model. Their user is entering his blood pressure, he's entering cholesterol and all these factors to identify heart diseases, cancer. So uh, we have that open source data available. So implementing machine learning models are having huge applications in medical industry. So on airport as well, like computer vision is working excellent. So no passport, no problem. Computer vision system inside airport take your photo to determine who you are, and whether you pose to safety threat. So basically, just by looking at us, it can easily identify who is the person, and the everything like information related to the person is getting gathered. So no more digging through the bags to find your ID. And the bank, basically computer vision makes opening of the bank account an easy two steps process. Take a selfie, join a short video call, no waiting in line, no piles of paperwork. So it's a great use case, and it's revolutionizing the way we live. So the farmers are using computer vision to find out which weeds, bugs, and diseases are damaging. So in agriculture industry, definitely computer vision is being implemented since a long time, and the agricultural problems are being solved. So people who are enthusiastic in learning artificial intelligence and computer vision, they are identifying the problems in the community, and they keep on like identifying the solution. How can we solve those problems with the artificial intelligence and computer vision? So it's a great capability that a people like a person can identify a problem, and you can come up with a solution. So let's get into the working part, how computer vision works. I'll be describing the step-by-step approach to make it very easy. So there are like at a high level, we can see there are like input and output device, interpreting device. So are you ready to start exploring computer vision systems? Let's dig right in. Vision systems are composed of two main components, so sensing device and interpreting device. So as I said, like sensing device is capturing the footage on a real time basis, and it's sending those input data to some interpreting device, whether it can be your local machine, or it can be somewhere on the servers. So interpreting device is processing the data and returning the final output. So in this image we can see like there is one sensing device taking the footage of fruits, and the interpreting device is processing the data, and after processing it's able to identify what are the objects available in the image. So we can see there is a bowl, there are oranges, bananas, lemons, and peas. So basically, object detection, which is the other terminology. Basically, after passing the image, it will identify the objects. We will understand it much better with with an example. So let's understand with an example. Suppose we have a bike and we have an image of a motorcycle, and we want the model to predict the probability of the object from the following classes. So classes are nothing but categories, whether it's a category of bike or whether it's a category of car. So these are like categories: car, motorcycle, and dog. We want to identify whatever image we are passing as an input, whether it's a bike, it's a car, or it's a dog. So it's a basic example for computer vision. So there are four steps basically implementing computer vision. We first provide some input, whether in a form of image or sensing device. So it's capturing the data on a real time basis, or otherwise we can pass which is already available in our computer. So let's say we have an image and we have passed that image to the model, and it's processing that image and it's extracting those features. Okay, it has bike, it has handle, and it has back seat, it has silencer, like that. So after extracting the features, it's able to identify like these features are available for bikes. Most of the bikes have these features. So it's deciding that, yeah, 0.85 accuracy is for motorcycle, and 0.14 accuracy is for car, and these accuracy is for dog. Basically the highest accuracy is for bike, right? So it's able to identify it's a bike. So let's understand each and every step. With this you'll have a clear understanding of computer vision. So these are like four steps. Remember the four steps: input, processing, and feature extraction, and classifier. So what is input image? We are going to look into the image with the computer perspective now. How computer treats an image, how one image is how computer looks at the image. So let's see. In computer vision applications, we deal with the image data or video data. Let's talk about the grayscale. So once we get the image in the pre-processing stage, we do firstly remove unnecessary colors, and we resize the image to reduce the processing time, as well as processing time and CPU. So it will be definitely lowering the load. So once we get the input, we have converted it to grayscale. Grayscale is nothing but black and white. So there are like 31 into the 15 pixels here. So basically input data is nothing but it's in a form of bytes like this. So whatever numbers we are seeing here, it's basically the grayscale level. So let's say the pixel over here, it's totally black on the tire, so it's zero. So if we see zero somewhere, it's totally black. And the pixel over here is white, it's 255. And function of x comma y, that is nothing but the position of pixel. So y-axis and x-axis, we can see like the position of this particular pixel is 9 at x and 14 at y. So it's 255, that is totally white. And there are some pixels which are gray, not even black, not white. So gray is having some intensity, it is 190 pixel, 190 intensity. So maximum it can be 255. So it's a color code. Basically 255 will be completely white, 0 will be completely black, and from 0 to 255 it can be gray, so with different intensity. So here we can see there is another pixel on 29,18 which is 190. So these are like hundreds of pixels available which are describing the color of image. It's nothing but the color of image, and what we see is like this, the context of image, but the computer sees the image like in a form of bytes. All right, so image is now converted, it's now broken down into smaller pixels. Each pixel is having a function of x and y and some value which is describing the intensity of color grayscale. And once we get the input, we have a function. As I said, the images can be represented as a function of two variables x and y, which defines a two-dimensional array. So two-dimensional array is nothing but like we can see like we have these x and y axis, so it's a matrix of multiple items. So based on the resolution, so if we have 25 into 25 resolution, so the pixel, the number of pixel will be like here we got, so 625 pixels will be getting. So similarly, based on the resolutions we'll be getting these pixels. So every image consists of a set of pixels in which their values represent the intensity of light that appears in the given place of our image. So as I said, each and every pixel has their own light value and the function of x and y, which gives the intensity and the position of it. So sounds very crazy, right? So we are getting into a much deeper part, how computer treats the images. All right, so you can see that the image above is the 24 into 24. The size shows width and height of image, 24 pixel horizontally and 24 vertically. That means there are totally 576 pixels. If the image is the size of 700 into 500, then the dimension of the matrix is 700 comma 500. So if we multiply these, we'll be getting the number of pixels with where each pixel in the matrix represent the intensity of brightness, and 0 represent black, 255 represent white. So we are clear with that. All right, so now we have got the input data and it's time to process the data. So in our steps we have the 4 steps. We provide the input data, we process the data, and after that we extract the features, and we come up with the output. So let's say the in most of the machine learning projects, the data processing and the cleaning stage is required definitely. Why? Because like we are getting the data from heterogeneous sources, multiple sources, multiple other formats. We need to have some standardized input. So in pre-processing, we remove the redundancy in the data, we remove the empty data, we remove the noisy data. Noisy data is like the unnecessary data which is coming with the input. So basically we are removing the unnecessary data and making it short and simple, which is required only for the desired output. So cleaning stage is a stage for each and every machine learning model. So whether we are passing raw data as a text format or a video or an audio, so a machine learning engineer, as a machine learning engineer, you'll spend a significant amount of time cleaning and pre-processing the data before building your learning model. So pre-processing for images, what we are processing in images then. So the purpose of this stage is to prepare the data for the machine learning model and making it easier to examine and process computationally. Before we feed the images to machine learning models, some data messaging is required based on the problem you're solving and data sets you are working on. So I'll give you an example. So here let's say we have provided this input, and during the pre-processing stage we are converting all the objects into grayscale, and to identify the objects we are making those objects with the colored, and the other one we can see these are those are like grayscale. So converting these are like techniques in pre-processing. First technique is to reduce computational complexity using grayscale. In certain problems you'll find this useful to lose unnecessary information from your image to reduce the space and computational complexity. So we are simply removing unnecessary things, like we don't want the all these signboards, we don't want the shop, we don't want road. Whatever we wanted to identify, we are just taking those as an input. All right, so removing unnecessary data and standardizing the images. So now we have input of hundreds of images. Those are having different sizes, different pixels, different resolutions. Standardizing images is the stage where we make height and width of the images identical. So each and every image will be converted into the same resolution, and then the standardized input is passed, so that it will save the computational time, and definitely will be getting the appropriate output as well. So it's very necessary important for us to pass the appropriate input. So after that, data augmentation law, so it automatically creates some other views of the data. So automatically it's changing the colors and positions, so that it can identify this particular object in a different scenario. So whether it can be in a dark or light, or in a flip or rotated version of. So data augmentation is simply making the augmented version of the original data. And another common pre-processing technique is to add altered versions of existing photos to the existing collections. This makes it more likely that your model recognizes object then they appear in any form or any shape, so we can identify it. Here is an example of the augmented images. So as of now, we have like two stages done: input data and image processing. So now that input data is ready to extract the features after pre-processing. So so in this image we can see we have a bike, and we have a feature extracted after implementing feature extraction algorithm. So feature extraction is a core component of computer vision. In fact, the entire deep learning model works around the idea of extracting useful features which clearly define the object of image. Right, so basically passing the image and getting the features out of it. A good feature will help us to recognize an object in all the ways we it may appear. So the characteristics of good features are: feature is nothing but basically identifying the components. So identifiable, easy trackable and compared, consistent across different scales, lighting conditions, and whether it can be in darkness or in a brightness, or different scales of resolutions, and different angles, still visible in noisy images. So noisy images is like let's say this image. So there is unnecessary data, it's nothing but noisy data. So it's still visible in the noisy data. Let's say if we want to get only the signboard, it's still visible in the noisy, the huge amount of data. There are many objects which are identified, but it's still visible. So it's a good feature that says so when only the part of an object is visible. So feature extraction is the third stage, which helps us to identify the final output. So here the deep learning comes into the picture. Like image classifier is an algorithm that takes in an image as input and output as the label or class. So as I said, after extracting the features, it's going to different patterns again and again using deep learning, and automatically forming different patterns of augmented images, and then uh, coming up with the final output, whether it's a car or no car. So yes or no, basically it's giving us the final answer. So for implementing computer vision, we have a we have an open source library called Opencv. So computer vision is a concept In order to implement computer vision in a real time project, what we need? So we need we need Opencv. So it's a library, it's an open source library for computer vision used for image processing and machine learning. Originally developed by the Intel, and Opencv supports wide variety of programming languages such as C++, Python, Java. So whatever programming languages we are working on, we can use Opencv, which is available in every different every programming, most of the programming languages. So right now we use Opencv with Python, and it also offers with the C++ and Java. So we are going to implement using Python. So it's also available on different platforms, including Windows, Linux, OS X, and Android and iOS. So basically this library can be implemented, and the solutions can be built on various platforms. So Opencv Python is an API which uses Opencv. So using Python, we need for using it Python, we need Opencv Python, which is just a module in Python. It works as an API. As I said, like we don't need to write the classification algorithm, and we don't need to write each and every line of code. We are having built-in pre-built modules. Like we just need to import the modules, we need to pass the input data, and we need to apply certain steps, and then we'll be getting the final output. So Opencv Python is also a similar kind of library, which is developed to use Opencv, and combining the best qualities of Opencv C++ API in the Python language. So we are going to implement it, and the library has more than 2500 optimized algorithms. So it's clear, right? So what's scikit-learn then? So apart from Opencv, we are also implementing scikit-learn. So scikit-learn is implemented for using machine learning features. So scikit-learn is the key library for Python programming language that is typically used in machine learning projects. Scikit-learn is focused on machine learning tools, including mathematical, statistical, and general purpose algorithms that forms a basis of many machine learning technologies. Some of the big key elements of scikit-learn useful for machine learning, including classification, regression, random forest, and clustering. So we have created a project recently, like in that there was a huge amount of sales data, and what we have done in that is like user is able to input some data. For example, it was like order history, and in that, like there are like 4 or 5 columns. One is male or female, the amount of cash he has spent, payment method, how many products he has selected, what was the day, and such so on, like few describing features. So basically, once user is entering the input, that he's entering some price, he's entering some products, he's entering gender, he's entering his salary, how much he's earning, and after entering all those points, we are returning whether this particular customer is going to buy the product or not. So using scikit-learn, we have implemented that, and it has like clustering and other many other benefits, so offered by the scikit-learn. So are you ready for the implementation? So sounds interesting. We have already built one project, so I'm going to execute it in front of you. So we'll start with the face recognition module. So this is nothing but my code editor. It's called as Visual Studio Code, if you don't know. And here we can see these are like steps I'm having. Firstly, inputting the data, pre-processing, features extraction, and after getting the final output, I'm performing those creating rectangles across the faces, and displaying the output in some form, like we can return the displayed output in the terminal or somewhere. So returning, I'm returning it to one image. So we'll be getting one image. So here we have got one image, and I'm going to implement computer vision opencv module on this. So here we import it as a cv2. Cv2 is nothing but opencv python. So while importing, just we use, so don't look at the syntaxes and don't worry about the code. It's very simple. You are able to, you know, learn and implement this within a short span of time, whether it can be like 15 to 30 days. So you can learn the basics of python, and you can implement opencv module within, you know, 1 month. So as I said, like, let's look into the logic instead of syntaxes. So it's a very simple code. I'm just going to run, which is taking, you know, input data as a test image. As I said, there are 4 guys in the image, and it's going to identify the faces. All right, so let's execute. The expected output is rectangular, you know, squares or rectangles across these faces. So I'm going to present it. All right, so I just need to click on the play button, and the magic of machine learning and computer vision will be happening, and you'll be seeing the output soon. All right, so we have got this image, which we can see the faces has been identified. So if you want, I can download some other images as well. So we can try. Basically, let's take team images, and there are multiple faces in the team. Can take any image, and we can implement the model. So I'm going to download this. So let me just download it somewhere and save it. Then I'm going to drop it in my project directory. So now the image name we have got, I'll just rename it to team.jpg. So team.jpg we are going to pass as an input. So it's going to run the algorithm. So simply clicking on the play button and sit and relax. Oh, nice. So we have got the faces, and it also provide the other information. If we write some more lines of code, we can get the number of faces, and you know, we can identify the faces using some different object recognitions. So we have detected the objects, we have detected the faces. We can also recognize the names as in the first example it was able to recognize it's a lemon, it's a banana, it's a bowl. Similarly, we can identify the objects, whether it can be a human, it can be a bike, or it can be a car. So these are like 4 steps: input data, pre-processing, extracting features, and showing the output in, you know, appropriate way. So it's a very basic example of opencv python, and hope it's very simple for you and sounds interesting. And another implementation we also got is handwritten digit recognition using scikit-learn. So we are going to implement handwritten digit. So there is another project for you. So for that I have a huge amount of data already present. So these are like different images, which is character digits written in handwriting. All right, so these images are as you know, we are just using these images to train the model. So we have these images, and the code we have here, which will, you know, take some random image from those images, and in the final output it will show you which image has been selected and what is the prediction for a prediction number of that image. So let's say, uh, if I run this, it will show up the output with the input data and the prediction. So we can see the accuracy of the model, whether it's able to recognize that digit. So here there is one handwritten digit, and its prediction is 1. So as we can see, every time it selects one digit, and the accuracy score is 0.98. So it's almost 100. It's almost, 1 means 100 over here. So let's see if we run it again. So let me just run it again. So we are just using the functions which are offered by the module. So uh, again it took 1 and the prediction was 1. So you can see like it's a different style of writing 1, and earlier it was different, but it's able to predict whether it's 1 or 2. Handwriting, it can be done on a real time as well. Like there is one tool where we can write the digit, and it will be passing that raw input data on a real time basis, like continuously processing the input data, and continuously sending the data to the program, and it's continuously returning the output. So it's like real time prediction. So let's run it again. So 0. Now we got the correct prediction. Again 0 with the accuracy we can see in the terminal is 0.98. So it's a great example, and there are tons of other examples available for Scikit Learn. So I have some resource which is like official website examples. If we just type Scikit Learn examples, and we have got this. So the one example which we did right now was like from the same, here we can see handwriting recognition. So detecting the same we did, right? So along with the code we are getting all these modules. So let me just show you some other examples. So here we can see implementing one algorithm along with the example and code. So all the algorithms offered by the scikit-learn has these many examples. So once you go through very basic, and you can get much deeper into this, and you'll understand what these graphs are. Look, so initially when I also looked into the code and looked into the graphs, and I got into confusion, like how these graphs works, and how like uh, the first program that guide showed me was like hundreds of lines of code, and uh, at my first look of the code I got I got scared. Oh my god, this many lines of code, like how he has written these many lines of code. And but later on, after going through each and every step, after learning each and every component of it separately, like these are like variables, importing modules, and using existing features, printing the output. So after joining all these components, or syntaxes, we get the final big script. So don't be scary. So it's very simple. After joining small syntaxes, we come up with the final solution. So these are the graphs which you can go through if you're like exploring more about it today. scikit-learn.org, and I can place it. So you just need to type scikit-learn examples, and if you want even your face recognition example, so everything like it's openly available on the internet. Opencv Python examples, so geeks for geeks, and many resources are there, like which are performing face recognition in image input, and as well as in the video inputs. So the best way is to go through some tutorials, and go through the tutorials and look how people are implementing, instead of directly implementation. Just going through some tutorials will be definitely helpful. So how is it, guys? Like, we have implemented 2 projects using scikit-learn and opencv. Hope you enjoyed. So the final topic, like we'll be covering the reason for getting into the artificial intelligence. So let's see reasons for getting into the artificial intelligence. So looking into this image, what you can understand. definitely you might have heard of these three revolutions, but artificial intelligence is the fourth revolution, and in the information technology, it's changing the way we live, and the day-to-day life has been drastically changed. And so basically the first revolution was stream based machines, that's the stream engine. And the second revolution, the stream engine, this was the revolution around like 1765. And the second revolution is the gas revolution, energy based. It was like around 1870. And the third revolution was the nuclear and computer based. Basically, the fourth revolution of the industry we can see is the artificial intelligence, information, internet, and like we are having big data and IoT. So all these technologies are like working together to provide excellent solutions. So IoT, big data, artificial intelligence, deep learning, we are implementing all the algorithms and coming up with the final solution. So getting into artificial intelligence is something like we are being a part of revolution. So if you want to be a part of revolution, you can join artificial intelligence. Definitely within few years it has emerged a lot, and going forward, it's going to have a huge contribution. And I'm going to present few points, like basically that is differentiating the opinion, differentiating the reasons. So one of the basic reason, yeah, like many candidates are joining artificial intelligence and data science is that we are going through many advertisements on social media platforms saying that like artificial intelligence and data science, it's very highly demanding skill and it's a training technology. So many candidates are joining artificial intelligence.
Yes, ma'am.
Hello.
Yes, sir, you're audible now.
Yeah, yeah, sorry, actually I don't know how it got disconnected. And just now Farid called me that yeah, you have got disconnected. So yeah, so basically I was in the point where let me share the screen. I think due to this disconnect there might be some issue. All right, so can you see the screen?
Yes, sir.
Okay, thanks for confirming. And basically it's the most important point, like what we are going to take away from the session. And what's the motivation behind learning artificial intelligence. So I have written few points. So most of you might have seen the code for the first time today. And most of you looked into the real project execution for the first time, and might be scary or might be crazy. So I have written few points where we can correct ourselves, and it can be a start for a great journey. Someone can be uh, from this meeting, someone can come up with the solutions which will be revolutionizing the whole world. So no, we cannot say like uh, if you start your journey right now. So I have a few points for you. So if you are starting your journey, it's very important for us to understand those points. So we have been discussing it since long time, and it's beneficial for many people around us, even my colleagues, and in even my working teammates. So basically, as I said, the first time when I looked into the code, it was like very huge amount of code, and I got scary. But looking into the code was very interesting for me. Print hello world was very like it was like very interesting for me. Print hello world, it's basically, every programmer's first program. Basically, when the first program, when we pick up any new programming language, is to print hello world. So it might be Java, Python, or any programming language. We The first program we do is print hello world. This one line of code can characterize our coding approach and provide us the most important secret of being a good developer. So understand these words. So basically, after gazing into this line, we just need to ask ourselves a question whether this line of code is like it sounds interesting, or it seems to be boring. So I'll tell you the fact. So if we think like if it's a boring thing, like we cannot spend much time coding, we cannot spend much time learning it, or it seems to be something related to your job. So there are like different thoughts we are getting into the mind after looking into the code. So the another in other hand, we can feel the craze and joy of it. This means that we found this line to be interesting and engaging. We want to know more about it, we want to try it, we want to spend as much as time possible to learn it. So after looking into these examples, so it might be very interesting or boring, but being if you got like yeah, it's very engaging, it's very interesting, yeah, I need to explore it more. So if you got these kind of reflections, then it's really a great sign that every successful programmer has a kind of love and attachments towards software development. So the perspective here is programming, or you can say you're learning artificial intelligence. So every successful programmer has a kind of love and attachment towards it. So they do it for passion, they do it consistently with attachment and motivation. So every successful programmer has this primary attribute that they love it. So right, so they are on the left, they are on the next level of creation, which is revolutionizing the way we live, and they appreciate the adventure and evolve with the passion. So that's what I wanted to say. Like these are like very interesting things. Like there are a lot of things to explore. We can be a lifelong learner if we come into the artificial intelligence. So it's very interesting. We can keep on learning new things each and every day. We can identify the problems in our community. We can come up with the solutions with computer vision, in our schools. And you can go to the business, local businesses, and you can sit with them and identify the problems they are facing, and problem and you can come up with the solutions with the artificial intelligence. So basically, the journey of each and every developer begins with the why. So today, most of you might be starting your journey towards artificial intelligence. So it started with the why we wanted to join artificial intelligence. So there are some reasons I have listed below. All right, so there are some reasons over here why we should join the artificial intelligence. So to learn something new, to solve the problems of our community, to express our creativity, to convert our ideas into product, and to bring the revolution. So these are like some important reasons we should join artificial intelligence. And we should eliminate these if we have. So we should not do it for money, or do it just for the job, or just for settlement, and because it's a highly demanding skill. So these are like common reasons which can even give you progress, but you can have a double speed progress with a broader vision, right? So with a great motivation and perspective, we can have the twice of the progress within the short span of time. So having a great perspective is it's a great start for the great journey. And even if we so let's look into the job. So getting a job is, if it is the option for us, then there is no other way for a developer to learn without going through trial and error. So basically, when we start artificial intelligence, definitely there are going to comes many hurdles in our way. We are going to face many difficulties, many errors, complex programs we are going to write and we are going to practice, right? So definitely there are challenges coming in the way. So if getting a job is just if we are learning solely to learning complex programs solely to get a job, we may consider changing the job. If we get stuck in the errors and consider and we don't understand anything, after all, why coding? There are other options available like digital marketing and so on. Many different options are available. However, if we learn to code for the love of it, it will empower us during the trial and error stage, because we are learning how to bring the revolution, and the failures cannot discourage us, right? So we have a bigger perspective. So if we do it solely to get a job, our perspective will be narrowed, and we will be limiting our talents. Instead, we should create a big vision to tackle the community's challenge. We can make more efforts if if we have a big vision, and if we can make more efforts, then we can make faster progress and level up our skill set, right? So now we have a different vision, and we have a we have a perspective that yeah, I have to learn something new which is very interesting, and with that I have a capability to convert any idea into a product, and I can identify the problems in the community and come up with a solution and make people's life easy. So that's what our vision and that's what our perspective now. So that's why we are getting into the artificial intelligence. So with this kind of big vision, definitely we'll be crossing each and every hurdle coming in our way. So we have the ability to study and develop anything we desire. I learned Python, I learned data science, everything like in my career, like I have started with a self learning approach. So that's what I'm stating here, that we can learn and develop anything we desire. So every day every developer picks a new skill and works on a new project. So new packages and frameworks and libraries are getting released every day to make our jobs easier. So every day we have to work on something new, we have to try something new. We cannot stick to a particular technology, or we cannot stick to a particular domain. So being a software developer, we are like lifelong learners. If we are getting into this industry, if we are getting into this field, that means we are going to be a lifelong learner. So every day we are going to try something new, something new. So whatever we learn in the university is just the beginning, and we may need to flip between different technologies depending upon the situations. Nevertheless, if we want to be a part of the race, we cannot rely on a single technology. So with this point, let's say if I wanted to learn the artificial intelligence to get the high paying job, or so I have taken a course where I have been taught all these modules, Opencv and Scikit learn. Let's say after learning some 10 to 20 modules, I came into the market and I started my career. And I think like now I'm ready for the job, and now I'm capable of delivering the output. So uh, if we are doing if we are doing that course, let's say it takes 6 months, or let's say it takes 3 months. So during those 3 months we think like, yeah, after completing these many modules I will be getting a job. And the clear vision over here is, after completing these modules I'll be definitely getting a job, and I'll be serving to the industry. So basically, if we have a different perspective that yeah, I'm a lifelong learner, yeah, daily I have to learn new things. Whatever I have learned is just the beginning. So that will definitely empower us, and keep us forward, and keep us moving. So having a right mindset has a significant effect on the overall development of our journey. And we should be coding for the joy of it. And the primary focus of joining artificial intelligence is that we have a capability and we have a power to make intelligent machines, and we can solve any problems we are facing in the community. So um, these are like many different points, but most importantly I just wanted to show you that having a big vision. And another point from the mindset is that most of my colleagues, they think that okay, Python, so it's a big thing, and database and server and artificial intelligence, data science, all these are like very complex and very big things. I cannot do that. So having a mindset that says everything is easy, everything is small, I can do it very easily. Having a mindset like it's very easy and simple. If many people are doing, why I cannot, like uh, even like I have trained many people who are not from the coding background, from banking industry, from telecalling. They came into Python and they implemented Python, data science modules, after 45 days, I'm just saying, like any people, like without even the coding background, are coming into the Python, and they are able to develop solutions within a short span of time, 3 to 6 months. So anybody can get into this field, and it's very easy. So if we think that it's hard and it's a big thing, then it's definitely going to be a complex thing for us. So if you're getting into the artificial intelligence, you think that it's easy and it's crazy, it's engaging, entertaining. And if you think the lock is very big, it's very hard to open. So if you think that the lock is very small and it's lightweight, so we can think like, okay, so we can unlock it very easily. So the mindset to start artificial intelligence should be like it's very engaging, it's very crazy, it's very easy. As I said, like I didn't require any instructor or any experienced person with me to learn artificial intelligence. I have just gone through many YouTube tutorials and keep on developing solutions, and that became my career. So I can show you the approach. Basically, you just keep in mind having a big vision, having a big perspective, and with a mindset that the artificial intelligence and the data science concepts are going to be very simpler for me. And the as I said, like huge amount of lines of code, it's not that thing. After learning small syntaxes and joining it together, you'll definitely feel comfortable to writing hundreds of lines of code. So within 1 month of training, or your self learning, you'll be getting hundreds of lines of code developed on your own. So with that mindset, we'll go forward. And you should have the confidence, that you'll be doing it. Definitely you'll be able to make it. So I have some image over here. So one of the big factor which I have seen in most of the candidates, they like they're not confident, whether they are able to do it or not. So before starting, uh, have a confident, like you are going to conquer anything. You are going to occupy. You are going to grab each and every concept with a huge confidence. You need to join, and definitely you are able to do it if you build confidence. So before building software solutions or artificial intelligence solutions, prepare the mindset and prepare your confidence. Yeah, I can do it, definitely I can do it. Then you can go through the hurdles, and then you can go through the obstacles. So how you can build a confidence? So I have simple approach how you can gain much and much confidence. So see here, definitely we are going to try, and we are going to get an error. Initially, without error we cannot build anything. So this cycle will show you how you can build a confidence. So let's say you have tried some OpenCV module which is recognizing the name of person. So after looking into the tutorial, you have tried something, and after that, you have got some errors. So there is one cycle, and one output is getting generated out of the cycle, and all these things are there. So let me just explain you the steps. So after getting the error, we are required to solve it. So uh, confidence is built when we are trying, when we build whatever we are trying to build. So let's say in practical, I wanted to go to some YouTube tutorial, or I wanted to follow one guide where I wanted to build one voice recognition system. So I'll just type voice recognition using Python. So after, let's say I have gone through Python basics and I wanted to learn voice recognition module in artificial intelligence, and I wanted to find some appropriate tutorial which is demonstrating the process. So let's say I have got one video which is having decent average of time.
When
Let's say
Hostinger gives you a price perfect
after
deal for web
following the
hosting,
7 minutes
you
of
know it's time
tutorial,
to
I
turn your
will
killer
be
idea
able
into a
to
new website.
understand
If
how
you
the
think
speech recognition is implemented.
to programming knowledge,
So I have taken a random tutorial which is representing the speech recognition. So as I said, before building solutions, build your confidence. You are gonna try one video where people are building solutions. So once you started developing speech recognition system using Python, you follow the tutorial along with the person to 7 minutes. So it took 7 minutes for that person, it might take 30 minutes for you. But after 30 minutes, following each and every step exactly how the person is following, and understanding the purpose of it, why he is using all those syntaxes, you will be finally able to build one solution after 30 minutes or 1 hour, let's say, right? So after following one tutorial, you'll be developing one solution, that is a voice recognition system. And imagine that you have developed 1 to 10 solutions, and how you feel that inside. Like after developing 10 solutions, I'll be feeling very confident when I take any when I pick up any new programming language. I do the same. I have recently joined Flutter, that is one programming basically framework which used to develop native applications like Android apps, web apps, everything. So after joining Flutter, I did the initially what I did, I started coding on myself. I just followed I just followed some I just followed yeah, there is documentations for each and every programming as we have for Scikit learn. So similarly, Flutter was also having one documentation like this. So what I did, I just followed the documentation and I got stuck in errors. And I was not able to fix the errors because whatever I was doing, I was trying to create something on my own. I was trying to create something on my own which making me stuck in process, how the process and the process flow, the project structure. So initially all those standards we need to follow, right? So I tried Flutter on my own initially, and I got failed in that because I directly jumped into the creation part, creativity part. I tried to show some creativity, but what I'm saying you is, instead of directly jumping into the creativity part, you just follow some tutorials around 10 projects you need to develop similarly as being developed on the YouTube. That's my approach. So after developing 10 projects, in every project you are developing confidence. And confidence, if you have the confidence, definitely you'll feel motivated. Yeah, whatever I'm trying to create, whatever I'm trying to develop, it's being developed, and yeah, I'm capable of doing it. And that's motivating you. And make and that's giving us the attachment with that particular language. So generally what happens, if we are not able to develop whatever we are trying, we get stuck into the process and errors. So that time we are not much confident, because like I don't know what happens, but whatever I try, it will not complete. It will be stuck into the error. So that kind of confidence will be very low confidence. So after developing 10 projects by just following the steps. So do you remember, we have followed the same fundamental when we are in the kindergarten. So do you remember, like when we tried learning characters A, B, C letters, right? So while we are in kindergarten, we used to mesh A, we used to mesh B, C, D. We are just following the path, right? A is already there on the slate. We are just copying, or we are just meshing on it. So what I'm saying, we just need to mesh the projects. So 10 projects, it's already there on the YouTube. We are just following the same path. We are just following the same path as we are meshing. And we are not going to stuck in this way, like we are not going to stuck in the errors or the process flow in this way. So successful completion of the project will be giving you confidence. So confidence will be apparently giving you the motivation and attachment towards the programming. And the attachment will ultimately give you the consistency. And if we are doing it regularly, consistently, with the motivation, and will be getting a skill set. Definitely after doing after practicing regularly practicing is the primary factor, guys. So because like even after taking up the course, if we stop practicing after few months, we'll not be able to develop anything. So practicing regularly is the main thing we need to keep up. So if we have motivation and attachment and consistency, then we'll be practicing regularly, then we'll be getting our skill set. So then whatever we try to whatever we think and whatever we try, we are able to develop. So the trial and error cycle of each and every programmer will be something like this. So whenever you are starting your journey, right? So I'll be showing you one scale. So this is time basically, and this is the success rate, whatever task we are working on. So initially whenever you try, the success rate will be at this point. So for few days you'll be stuck into the errors, or you'll be understanding and observing each and every code. But after fixing and overcoming all those obstacles, so you'll be able to develop something, and but stuck at some another thing. So few tasks are being delivered and some tasks are not delivered. So trial and error stage. So this span is the trial and error span. Definitely we need to go through this span, and after we are out of it, then we'll be like this, like whatever you try, you'll be able to deliver it. So in my career, initially I struggled for 2 months. The time of this trial and error was the 2 months, but for you it can be different. It can be 1 month for 15, or it can be 4 months. I used to code 16 hours a day, but you can spend as much as possible time. So the main motive for spending 16 hours of time is like I wanted to complete the progress which I wanted to do in 2 years, in within the 1 year. So like with the uh, half of the time. So the more you spend time, the more faster progress you will have. All right. So trial and error will be there, and definitely you don't need to scared of that error. So you just need to come out of this span, and once you are out of this span, then the magic happens. So most of the programmers, they drop over here. Some people, they drop over here, that yeah, I'm trying to do, but it's not my cup of tea. So most of them, they drop here. But if you have courage, and you just go through many, Stack Overflow is the website, and there are like many tutorials to solve the error. So there is no error available which does not have any solution. Each and every error has got the solution on the internet. Even small syntax error or big conceptual errors or fundamentals, everything, if you search it, you'll be able to get it within the minutes. So you just need to come out the trial and error. And during this stage, I'm asking you to just follow the mesh fundamental, and build your confidence before building the solution. And that's it. You'll be in a track. Definitely you'll be doing it for the consistency. And yeah, basically another approach I have, yeah, to grow yourself as an artificial intelligence engineer, you need to share your knowledge. So it's a big factor. If you wanted to learn something, the best way is to teach someone. So it was like my the the part of my journey that I have basically anyone who teaches, he's actually getting more confident and more clear in the concept. So if you are learning artificial intelligence, find someone, might be your junior. So sit with them, or get them into the Google Meet, and teach them whatever you have understood till now. So then maybe takeaways from this particular meeting, you can explain it to your juniors. So uh, once we share the knowledge, we get more knowledge. So I believe in this, because from the day 4 of my journey, I started teaching, I started teaching someone who has like years of experience in non-technical field. So I was just 4 days of my journey, and whatever I have learned in first 4 days, I started delivering that to some madams. There are like they are in banking and finance sector. They are like having 10 years of experience, but I'm just explaining them JavaScript what I have learned in 4 days. So don't think that you don't have enough to teach someone. Yeah, I have 4 days of experience, and I started teaching that to that madam. And apparently, like, I followed up with my juniors, and then I got everyone into the Google Meet. So there were like 15 to 20 people, and I just shared them whatever I have learned in 1 month or 2 months. So keep sharing the knowledge that will, result in more and more knowledge. So that's, very important for us to share the knowledge. And the other thing, uh, yeah, I think, keep on sharing the knowledge, and the more important factor is passion. So these are like my personal suggestions when you're coming into the artificial intelligence. These are uh, points that can be considered. So have any questions? If you want, I can share you the PDF. Basically, this will be giving you just an overview of the whole journey of a software developer, and these attributes, making us, empower us during the trial and error stage, and very important points to, grow as an individual. And the approach basically is to learn on yourself, and the approach basically teaches you to find the abundance of knowledge instead of thinking that someone is required for you to learn something. You can try on your own. As I said, you just need to go through Python basics, which will take around 1 week maximum to cover the Python basics. And you can get into the implementation part. So while developing solutions, you'll be able to understand much and much, even more syntaxes which you don't even know. So while developing the solutions, if you learn, that is the practical approach. And so whatever we have learned in practical approach, we will be able to understand, and will be able to grab it for the long time. So hope that the clear I've tried to express as much as possible, as meaningful as possible with in terms of OpenCV and the Scikit learn. So I think you can share me your point of view, or you can have any doubts. All right, guys. So I'll just show you an approach, right? So uh, let me just organize the content which I just shared you. So we are getting into the artificial intelligence now. Maybe some might have taken the decision to, solve the problems of the community right away, and some might be thinking it to the in the future, like whenever you wanted to join, you can join. But I'll be sharing you the approach, that how you can grow as an individual, and how you can start your journey, and you can try the things. So that's the approach here. So let me just show you the approach. So in the approach, I'll be explaining, like, nowadays a person can learn software programming on their own without the assistance of another person or instructor, because the resources are widely available on the internet in each and every, language. So if you know Tamil, if you know Telugu, or if you know Hindi, you can search it in your language, your native language. So whether it can be English, or it can be Tamil. So resources are always available on the internet. So our approach must be like, we should adopt a self learning approach, and we should be self exploratory. So the benefit of that is, we are open to an abundance of knowledge if we believe we can explore and learn it on our own. Whenever we need to learn something, we go to the internet, look it up, and we discover our own path by going through the trial and error process. The knowledge we gained after the hardships is extremely valuable for us, and has a significant impact on our success, right? So many concept which we have, adopted from, many hardships, we have gone through many errors. to understand that logic, we spent hours of time, we have spent many days and nights to grab that concept, and finally we are able to build a solution. So in the self learning approach, practical approach, definitely you'll be getting more errors, you'll be getting more hardships, but this knowledge which we get from the hardships will be having a significant impact. And that knowledge will be having a different kind of respect in ourselves. And whatever we learn, let's say I'm just sharing the information and you're just listening to it, and you're not while we are just listening to it, we are not that focus level that we have in practically implementing. So while we are doing it on our own, we are very much focused, and we are very much clear that why we are required that concept. So let's say I wanted to recognize, I want to recognize the student with the face, and I want to put the attendance. Okay, so the requirement over here is to identify the face of student and add the attendance. Automatically we are taking the attendance of the student. So for this particular requirement, what might be the logic? So let's say we just need the image processing system, which we can use using computer vision. So we need some input data, hundreds of students images with the label. So as I said, I have a folder here which shows the image and the labels with the label. So see here, all the images to this particular label, that is 2, are available. So 2 in different formats. So this is how, like, we need the images of student, multiple images of each student with a label, with a name actually. So once we pass that input data, and we pass the camera. Now we are passing the camera footage. Now the student is, once he enters the school, he comes in front of camera for a minute, and camera is capturing the image and displaying a message that capturing the footage, and recognizing or something like, to engage the student, to not make that student bored, he's showing some output on the display. And meanwhile he's processing his image, and finally is able to detect the name with the face. So the for this particular requirement, what's the logic? We just need to recognize the image, and we need the input data. So basically, while we have something, uh, while we do it practically. So what I'm trying to say is, whenever we do practically, we have some requirement in front of us for which we are trying to build a solution. And for that, I'm researching how to recognize the faces, and I came to know that OpenCV is the module which is used for recognizing the faces. So while we are implementing the solution and we got this solution, we are very clear that yeah, OpenCV is implemented for that particular reason. So similarly, any concept which you are learning as per the requirement will have significant impact on the memory, and you can learn it much with the much interest, and more interest, and you can remember it for the longer period. So it's always beneficial for us to have some requirement, have some practical example in front of us, and then try to identify the solution. So logic is nothing but breaking down the requirement into parts. So the requirement is the student images and the student face, the real time camera, and then capturing the footage, recognizing it using OpenCV, and displaying the output. And after we get the final output, whether it can be yes or no, or let's say it's a car or not, no car. So we can say, like, after passing the input of student's face in a video format, it will be implementing feature extraction and classification, and identifying that the roll number of this student is that. So basically, after identifying the phase, we just need to enter the attendance. So after breaking down our requirement into multiple chunks of logics, we are able to develop a solution. So for each and every requirement, we need to search for the solutions. Let's say if I wanted to recognize the phase, how to recognize the face. You don't even know what is OpenCV, or you don't even know what is computer vision, but you are trying to you are trying to find the solution for it, and you have selected a particular programming language. You are working on a project using Python. So basically you wanted to recognize the face of a person. So you're entering the requirement whatever you have got in your logic, and that requirement will be giving you what we require to build the solution. So uh, in all these modules, you'll be able to see Opencv Python, and you'll become once you go through these blocks, you'll able to rectify, okay, there is one module called Opencv which we can use for face recognition. So having a practical example and then coming to the theory part. So generally what we do, we just go through the theory part first. So just now we did, right? We just gone through the theory part. I have explained the computer vision steps. These are like theory parts. So after going to the theory, after going through the huge amount of theory, uh, we start coding and we start developing. That is the theoretical approach. So there is another approach called practical approach. There are two, basically we can try theoretical and we can also apply practical. So the practical one is that we search for the requirement, and we always have our mind clear with the requirement. So whatever we are whatever concept or whatever algorithm we are going to implement, we know the purpose of it, we know where it should be implemented. But when we are going it through the theory part, when it comes to implementation, we are lacking that capability, that we are not able to implement on a huge scale. So developing programs to learn, so in a theoretical approach, we learn all the concept syntax in order to start. So sequentially, generally it happens, right? When we join any programming language or any course or even in our college, so we go through some basics, and we go through some 10 programs, so sorting algorithms, and we go through some real time industry programs, so that are already used widely. So in theoretical approach we go through all the syntaxes sequentially, but in practical approach we start with a very basic knowledge. As I said, you're going to require Python programming language or a Java programming language to start with the artificial intelligence, right? So you just need to go through Python basics. You must be clear with the mathematical concepts, and then uh, you are having to start with the practical example. So no need of having all the syntaxes, like all the concepts available in the Python, like how to read a file and how to connect the database, and how to perform data structure transformations, and how to do all the stuffs in Python, and then getting into the artificial intelligence, which is a long path. I'm just showing you the fast track how you can quickly get into the artificial intelligence. You just need to have a basic overview and understanding how Python is executed. Okay, what are the overview topics of the Python? So generally what I do when I start any new programming language, so I have came across 25 programming technologies in last 2 years. So every time I go through a source, so let's say W3 is a source, W3 schools. uh, Here we are having the overview, and you'll also get that OpenCV modules and everything over here. So connecting to the my Python and machine learning models. So it's an overview. You just need to find a source where each and every topic will be covered. All right, so we have now a big picture that Python also have the database connection, Python also has the modules, Python also has the MongoDB, and Python also covers the machine learning matplotlib and all these concepts. We can work with files. So having a big picture, it's enough. And how to implement, we are clear with the syntactical standards, how we are going to write the code, how we are going to fix the errors. So once we have that process flow smooth and running, we are able to create small programs like coding a small calculator which is just returning two digits by addition or multiplication, subtraction. After simple calculator, you might be doing some
basic Python programs which demonstrate the process of banking, like one saving account, he's having some value, and after withdrawing, you're reducing some value, and then after depositing, you're increasing some value. You can demonstrate these processes using coding. So having practical approach is definitely, having the fast track for us. Definitely, whatever concepts we are going to learn throughout our journey, we are clear with the implementation. We are clear with the logic, and we are clear with the basically requirement of it, why we need to use it. So generally, when we are very early stage of coding and the development, we were not able to understand like what is these sorting algorithms are used for, like what are these modules used for, because we have gone through each and every component of the programming language, and we are confused, like why they are required, by where they are implemented. So that's the reason I have demonstrated two teams here. So I think you might not be able to look into it as it's very small. So there are two teams over here, as you can see, team 1 and team 2. The light colored bar, it shows how many syntaxes they have learned, and the dark color, this it shows how much capability of development they have, like how much they are able to implement. All right, so the team 2 has more syntaxes, but they are able to develop less. The team 1 has less syntaxes, but they are able to develop more. So here I have just demonstrated that, like if we go through theoretical approach, we have many syntaxes at the end of the program, and after implement when it comes to implementation, after even completing 30 days or 45 days of training, when it comes to implementation, like whenever someone asks you to write some logic, or when someone asks you to build some sort of solutions, uh, we are lacking that implementation part, because we are not clear with the requirement, why Opencv and why these things, like where exactly it stands in my in my architecture. So while going through syntactical approach, we have very much syntaxes. Yeah, the for loops. Yes, all the fundamentals and all the concepts, but not clear with the requirement where they are used. So development can be, development capability can be lesser. So when it comes to practical approach, so team 1 over here is a practical, they have implemented practical approach. So they are learning while developing, and they are clear with the concept, and they are clear with the requirements, so they are able to develop more with very less amount of syntaxes. You can develop many things, just by like 10 to 20 syntaxes. You can develop many solutions just by 10 to 20 syntaxes. So it doesn't require hundreds of syntaxes to develop a solution. With one syntax you can develop multiple solutions. Similarly, like with one module you can come up with many different solutions. Like let's say if you wanted to send email with Python, you can send OTP, you can send newsletter, you can send invite, you can send if you have shared file, that notification you can share. So one simple syntax has many different implementations, right? So when it comes to practical, we are more at implementation part. So going practically is the best approach, I think. And then uh, the strategy, like why I'm presenting the practical approach, it's a strategy. Like once you understand that, yeah, I can go practically, yeah, the whatever I want, it's already available on the internet, and I don't need any assistance. So you start exploring yourself, you start self exploration and self learning. You don't feel dependency on some any institutions or any other. You just feel independent with this approach. Just start exploring, and whatever so far, you just start implementing from that point. And after going till that point, you'll understand the next step. So if 10 steps, you just follow 10 steps, and after following 10 steps, you'll automatically recognize the another forward coming 10 steps. So if you follow 10, 20 steps, next 10 steps will be automatically coming in your way. So this is how you keep on exploring, and you till get the abundance of knowledge. So this is a strategy basically, which we are discussing. If you follow the practical approach, you will evolve as an individual and as on your own, and you're clear with the steps, and you can keep progressing. And here I have just implemented, like, within the first year of my coding, after implementing the practical approach, I have been around 12 technologies which I was offering for my company. So within the 1 year, 12 technologies, and within the second year of the career, 20 plus technologies offering to the company. It was like extraordinary, progress, which I think, after going through practical approach, after sharing the knowledge, after having the right mindset, after having the confidence, these are the factors. Like, if we take all these factors along with us, it will help us and empower us throughout the journey. And artificial intelligence, it has, definitely it has, a lot of things to explore, and it's a very entertaining and engaging. Once we get the final output, which is the predicted number or the predicted digit, you feel very, exciting, you feel very happy to get that final prediction result. After you develop one solution, you can, taste it, how it feels like once you deliver one AI or ML model. It's very interesting and engaging. You can definitely give it a try. And the very basic example, as I said, you can just type face recognition using Python, image recognition using Python, or a small. You can start with a very small baby step, and then you can later on get into the bigger concepts, like logistic regressions, or implementing on the bigger data sets, thousands of rows, thousands of columns, and getting the final results after following 10-20 steps. So better you can, go through the basic example, like as I showed you. There are 4 simple steps: taking input, pre-processing, extracting, like this, like 10 to 20 lines of code, and you'll be getting the final output within the 20 lines. So these kind of examples you can explore on the internet, and then you can try. And if you want to definitely get into the advanced part, there are like tons of courses and tutorials available. And you can, start exploring. So is there anything stopping your way? Is there any doubt or confusion towards it?
Sir,
Yes, please.
good morning, sir. Sir, my name is Anurag Sinha from BCA department, sir,
Hi, Anurag. Yeah.
in Hindustan Institute. Sir, actually, I just got one doubt, sir. The thing is, I mean, these concepts like the thing is facial recognition, computer vision, such concepts we can also use it for making robotics based project, right, sir?
Exactly.
These concepts which you just thought today.
Exactly. See, these are
Okay,
like
sir.
concepts which works as a machinery. Let's say you have an industry, you have a factory. There are different machineries. Let's say one machinery which takes the input as images and gives you output as the recognized, or as the classified output of it. So the output can be served in a different ways. So artificial intelligence models are there. There is one machinery, there is one module which is taking input and giving you the output. So in my current example, I have presented the output in image.show. So I'm showing just the image. So similarly, the output can be in a different formats. It can be a robot, it can be an Android application, it can be a web application. So basically, this is the engine, and the output can be presented in different ways. So if you are even passing this real time image to a robotic camera, and camera is displaying, or camera is giving you the output, hi Anand, hi Anurag. So camera is greeting the person on a real time basis. So that can be implemented even in robotics, or it can be implemented in terms of web application or Android application.
Oh, okay, sir.
So we have the engine that is generating the output. We can just serve it anywhere, wherever we want.
Okay, sir. I mean, the thing is, output can be in a different format, such as like robotics,
Robotics.
electronic based output, or
Yeah.
computer based outputs. That depends. Okay, sir. Got it, sir.
Yeah, you got it. You got it right.
Thank you, sir.
You're welcome. So here the curiosity begins. So he's getting doubts, he's getting questions now. So this is where the self exploration begins. Whatever questions you have in mind, just start exploring from that point. So can we implement AI and ML on robotics? So just keep on digging inside and gathering more and more knowledge, and will recognize the surrounding technologies. So initially, I was not aware of actually this OpenCV, and I was not aware of Scikit learn. But these surrounding technologies, I came to I came to the implementation part when I just typed the question, like how do we recognize phases, like these surrounding technologies. If we keep on self exploring, we'll get new and new. So let's say if you're looking for business intelligence tools, so while you're working with Power BI, I mean Power BI is a business intelligence tool which takes the input in a raw data format, and it will be giving you the charts and analytics, automated charts and analytics. So see like this, so you'll be passing basically some CSV Excel sheet data, and it will be generating charts. So while you're learning Power BI, you'll be getting aware of other integrations related to the Power BI, and similar products other than Power BI. So the surrounding technologies will come across with the surrounding technologies, and we are required to learn even the surrounding technologies. This is how we expand, we keep on expand our skill set. So I think there is some doubt.
Hello, sir. Good morning, sir.
Yeah, good morning.
Myself, I'm Triani from Master Professor from St. Xavier's College. I have a question.
Yeah.
There are many apps we can do Python coding, like PyCharm, Spider, Jupyter, and Python IDE. And which app is better to do the coding?
So
Python
my
coding.
personal suggestion, I have been always using Visual Studio Code. It's lightweight, it's easy to understand. It does not make your journey more complex or more
Okay.
it's very lightweight. You can see the user interface, it's very simple, and there are like tabs, no extra things, right? So
Okay.
there are more
Hmm.
ideal ways which it's very simple. Just open any folder which you are required, write the code, whatever language you have, it will automatically detect the language, and it will just click the button and play. So there are like PyCharm, and mostly Spider ideally, Ellipse ideally, Eclipse ideally. Why they are used in in ML or data science fields is because they provide a great environment for development. Because whenever we are working with Python, we have several modules. So one OpenCV is one of the modules, Scikit-learn is one of the modules. So we just install whatever module we required, and we keep developing. So in Visual Studio Code, we install a module like this. So pip install Flask. I've just entered one command over here, and it's downloading that module. So
Hmm.
similarly, if I want to work with OpenCV Python, I just type pip install OpenCV Python.
Okay.
So in that, ideally, you will be having a separate virtual environment where all these dependencies and packages are being managed, and it will not conflict
Hmm.
with your local machine configuration. So for each and every project, you will be having separate environment, and you will not be complete. See, there is one version for each and every dependency. So Python CV version 4.5 is required for this project. Let's say I have developed a project 1 year ago, and it has 3.5 version. So having
Okay.
different virtual environments for each and every project will not conflict these dependencies. Definitely there will be some changes from 3.5 to 4.5, right? So my existing
Yeah.
project should not get disturbed. When I'm creating a new
Hmm.
project, it should have a different environment. So that's the reason we use Eclipse and Spider to manage it in a better way, and focus only on the
Hmm.
development part. So we'll not be struggling with the dependencies and conflicts. We'll be straight away managing the dependencies with the ideally. So
Okay.
but it can be definitely done with the Visual Studio Code, as I'm doing everything with the Visual Studio Code.
Okay. Okay, sir. Is there any coding difference between apps?
No, the difference, like the various features they offer, like Visual Studio Code, it has
Mm.
wide range of extensions. But you can work with
Okay.
Dart, we can work with Python, JavaScript. There are like snippets, for example, if you are working with HTML or any programming language. So it provides you
Mm.
facility to auto suggest the code before writing the whole syntax.
Okay.
It will suggest it
Mm.
like this. So many
Okay. Good.
different facilities are there in Visual Studio Code. That's the reason each and every compiler has their own features and unique features.
Yeah. Okay, sir. Okay. Okay, sir. Thank you so
So you can
much.
start with any program, any compiler. No, no need to worry about any. You can start with anyone. So you can follow the tutorial on
Yeah.
the YouTube to set up.
Mm.
That ideally, just 5 to 10 minutes of
Mm.
tutorial will be enough. Then you'll be clear with the ideally part.
Okay, sir. Okay.
You're right.
Okay, sir. Thank you so much.
You're all right. I think all these points has enlightened a spark that you should join us in the revolution of artificial intelligence. And whenever you find some questions or difficulty, you can approach our team. And uh, you can also share us your experiences in your journey, whatever you have been able to achieve. Uh, so we'll be trying to keep in touch with you.
Sure, sir.
Yeah. I'm waiting for it to take over. If you want this small ebook document, I can share the link. So whenever you got some time, you can go through these points again, because like whatever we discussed, maybe we forgot after few days, right? These are very essential points that you can remember whenever you are required. Okay. So I can share the PPT and as well as the document with you, so that you can recollect this information. Okay, I think chat channel in meeting is only available to team members. I'll ask my team member to share the links. Okay. Hello, Farid.
Okay, sir.
All right.
Okay, sir.
Yeah, yeah. We'll be waiting for the next thing. So
Yeah, Muzaffar, I'm here. So
okay.
the participants having any doubts, so they can ask.
Yeah,
If
I was
not,
actually requiring to share the link, but it's not allowing here. So can you just share the link? I'll just share you. I think you have these links in your Gmail, because I have shared you already. So
yeah,
it's
yeah.
better like
They with Satish, sir, so he can post in the chat also.
I think chat is not enabled here.
Yeah, that's what I'm asking Satish sir to enable the chat so that we can paste the
Oh, okay,
links.
okay, okay.
So that
Hello, Satish sir.
Mohammed,
Hello. Hi, sir.
Farid, Farid. You know,
Hi, sir.
Thanks. Nice session, Mohammed. So
Thank you, sir.
now, Dr. Gandhi, much rate of time.
Yes, sir.
1 minute, 1 minute, 1 minute.
Vrinda, Vrinda, so I hope the question and answer session is done. If there is any question, yes, you can proceed. Okay, I take it as no. Thank you, sir, for an enlightening and informative presentation on implementation of Scikit Learn Python library. I'm sure we
Yep.
had a lot of takeaways. Rather than being informative, it was actually motivating.
Thank you
So,
so much.
no further delay. Thank you. No further delay. May I request Dr. Gandhimati, MCA, Hindustan Institute of Technology and Science, to deliver the vote of thanks. Thank you, Brenda. Okay, I would like to thank Mr. Mohammed Abdul Farid and Mohammed Musarraf, Senior Software Engineer, Accenture, Hyderabad, for making an excellent presentation and making this workshop very meaningful and interesting. The session was full of knowledge and interesting things. It gave a deep insight into the topic of Scikit Learn for computer vision and also provides some interesting facts. I am pretty sure the previous knowledge that the Muhammad Abdul Farid gave us will definitely help us in studies and future of the students. Thank you very much, sir.
You're welcome. It's a great pleasure for us, and it's a great opportunity
Sir,
for us to talk. Thank
Brinda.
you so much. Madam, I just wanted to share the PPT and the document link so that we can go through it again.
Brinda? Yes, sir. Thank you, sir. That would be really helpful, and we are grateful for that too. Brinda, can you conclude that session? Am I audible, ma'am? Ma'am, yes, like, sorry, I did not hear you. Yes. Thank you, participants, again for joining this interaction and making this a productive one. So this is not all. We have the next session in sharply at 1:15. You have to join. Make sure you join sharply at 1:15, and you can take your break now. Thank you. Thank you all. Now share feedback.
Thank you, ma'am.
Shared, ma'am.
Okay.
Thank you, Mr. Sasa, for the session.
Thank you, sir. The
Shall we leave?
session was useful. Thank you, sir.
Shall we drop off, ma'am?
Thank you, sir.
Mustafa.
ಇದು ಇಲ್ಲ and participants are expected to gather at 1:15 p.m. Make it sharply.
हाँ भाई, वालेकुम सलाम, निकल जाओ।